So hello guys, you are welcome back. You are welcome to Easy Tech Academy. So this is a mobile chip level class. So going on Easy Tech Academy channel. Okay. All right. So in continuation of our class, so we talk about how to track Fibos ray in our last class. Okay. All right. So which is the basic level of mobile charging problem tracking way. Okay, so this is where we stop, whereby we are using Infinix or 10, that's X6 A2 as a practical case study. Okay, all right, so this is where we stop. So we talk about how to trace the fibers, so from the charger, so uh, through the process of OVP, and then to the inputs, capacitor. Okay, so we talk about how to trace them. Okay, all right, so now I have told you that we are dealing with these two guys. Okay, we are dealing with these two guys, fibos and vbat. So I told you that that's the basic knowledge and basic troubleshooting of mobile charging circuit. Okay, or charging fault. So whenever you are troubleshooting, basically you are finding fibers and vbat. Hope you understand. Okay, all right, so now let's continue in our class from where we stop. Okay, so we stop at this range. So I told you in the last class that for fibers, so the convenience testing point for input of fibers, that's the voltage that the charging IC, this is the charging IC, that charging IC we use to start a work and subdue to the particular voltage required to charge a battery. So you can check your input here, you can check the 5 volts for here. Okay, I told you that this is a ball IC. So in order to check anything along this side, so we have two type of IC. We have a ball IC, okay, and we have leg IC. Hope you understand. So this particular charging IC, we also have leg charging IC, but mind you, most of the charging IC that is coming on our latest phone now, they are usually ball IC. You understand? So now I told you that that's the convenient point to test it, and if you want to test, you have to remove the IC. Okay, all right, so now when the fibers enter into charging IC, okay, the work of charging IC, I have told you in the last class that 5 volts is not a voltage that is required to charge a battery. I have faced some issue that I will solve 5 volts. On battery connector. Yes, I have seen some cases like that. So whereby I will see 5 volts on battery connector. 5 volts. 5 volts will appear here, this area. Yes, I have seen many cases like that. So the reason why is that the charging IC is not doing the work, and in that case, when I see a 5 volts in this battery connector, do you know what happened? This is the power IC. The power IC will start getting extremely hot, very hot. The power IC will see that voltage as a high voltage through the sensing resistor. Okay, so if you do not quickly remove the charger, So within 1 minute, the charging IC will die because that voltage is too much, and we are expecting a VPH. So in VPH line, we have like 5 volts, and this VPH is going to, that's the input voltage for the power IC, and in that case we need 3.7 volts to 4.2 volts to go to power IC and other mobile section through the VPH line. But now we are seeing a 5 volts. Why? Because charging IC is not doing its work. Okay. All right. So I have seen many cases like that. Even though I have seen a case that later on the power IC short because the customer doesn't know what is going on. So far is putting the charger to it, is killing the charging IC because this charging IC is not stepping down the 5 volts. So in vbat you're supposed to have from 3.7 volts to 4.2 volts, and mind you, that's the voltage required to charge the battery and go to other section, and this is the particular voltage you are going to see in VPH power. Okay. All right. So that's the fault whereby charging IC also give out, because charging IC, this is a buck coil, this is a buck coil, this is a buck coil, this is a buck coil. Okay. What is the major role of this buck coil? Whenever you have a buck coil, just know that you also have what we call buck converter IC. So let me give you introduction to that. See, any IC that step down a voltage, is recognized as buck converter. You understand? Okay. And listen, whenever a buck converter IC is placed, you will see buck coil. And what is the work of this buck coil? So next time I will be telling you about the work of the buck coil, but let me just give you a brief. So what the major work of this is buck coil is that is defending fluctuation so that it will not fluctuate. You understand? So that's why it's defending. So it's defending a reverse voltage. Okay, so that this voltage will be stable and not fluctuating. Okay. All right. So when we are talking about basic of schematics reading of electronics, so we go deeper on the function of those, how this all those basic components work. You understand? All right. So in continuation of what we are saying, that charging IC is recognized as a buck converter IC because it stepped down a voltage. What is the voltage that is stepping down? The 5 volts to 3.7 voltage to 4.2 voltage. Hope you understand. All right. So after then, when the voltage is out, so the convenient testing point for vbat, you can see this is the output capacitor. So you have to check your vbat here. So if vbat is not getting here, just know that your charging IC is not giving out the voltage. And listen, this capacitor also can be faulty. Okay, so if that capacitor is faulty, so there may be a problem in your charging circuit. All right. Okay, so you can see that this charging IC is doing two things. It's giving out a vbat voltage and vph power. I told you in the first class that if you remove this type of charging IC, the phone will not power on. It will not power on. Any charging IC that is giving out a vph power, if you remove it, the phone will not power on. So but if charging IC is not responsible for giving out vph power, or if another source, or there is another DC to DC IC that is giving out vph power, so mind you, if you remove this charging IC, phone will still power on, but the phone will not charge. Okay, all right. So this means that this charging IC can cause total dead, can cause dead, can make, if this charging IC is faulty, the phone will dead. And there are some charging IC, if it's faulty, phone will not dead, but it will not charge. Just that such a charging IC is not giving out a vph power. Okay, all right, so take note of that. Okay, so now you see that it's doing two row. It's giving out vph power and vbat, and this vbat is going directly to your battery to charge your battery. You can see. So this vbat test point, so you must have 3.7 voltage to 4.2 voltage present in on this guy battery connector. Okay, all right, so that's how to trace. That's the basic tracing of charging section. And when we are talking about buck converter, also your power IC also is a buck converter, because we have a lot of buck converter IC inside it. In power IC, we call that IC LDO. Okay, so LDO in old phone also have standalone IC, but it was integrated inside the power IC. That's why around the power IC we also have buck coil. Okay, all right, so that's not our major that's not our major class today. Okay, so that's the basic of how to trace charging circuit. Okay, vbat, you are finding a vbat, you are finding the vbus. Okay, so that's how to trace. Okay, all right, so in a pro level tracing, with the one you learn on EasyTech channel now as a basic level for tracing a charging fault, you will be solving some common problem. Okay, but when we are going in deeper of schematics understanding, there may be possibility that charging IC is good, but this feedback voltage will not be out. Why? Because the charging IC is not receiving some signal. So that's pro level of schematics understanding. So in that case, we have to go to the architecture, the diagram of the charging circuit. Okay, all right, so that is coming on EasyTech online training class, okay, which is on process. All right, so you will learn everything from basic to advanced. All right, so I hope you enjoyed this class. Okay, so if you enjoyed this class, so try to subscribe and like the video, and also I want to see your comment. Okay, so drop your comment in comment section. Okay, that's right. All right, so love you guys. Bye for now.